Hi, I'm Sabrina.
I'm Kavina.
And I'm Fiona.
And welcome to
The Couch Potato Lab,
where we bring the science to your own homes. I'm Sabrina, and I'm your host for today. Make sure to follow along with our lab manual that you can find at bit.ly/couchpotatolab. You can follow along with us there and have some extra activities to do when we're done. Also, make sure you text us your questions, what you're doing, that you're following along with us if things are going right or wrong at our cell phone number at 1-306-570-1013. So we want to get started today by introducing our wonderful scientists. So who do I have on my left?
Sabrina, you have Kavina. Hello, everyone. My name is Kavina. My pronouns are she, her. And do you want to know a fun fact about me? That's usually what we do around here, right?
I would love to.
Fun fact about me is I am very excited to celebrate Pride Month this June. So that's what I'll be doing all month, is researching some queer trans scientists, learning more about them, and celebrating all of our LGBTQ2A+ folks at home and scientists.
I love that. That's awesome. Okay, and my name is Sabrina. Like I said, I'm your host for this afternoon. My pronouns are she, her. And a fun fact about me. Okay, so my dog, I've been trying to, she's an outside dog. We live on a farm, so she loves to be outside. But recently, she had a surgery, and so I slowly convinced my parents to let her be an inside dog, and she has started sneaking from her bed and sleeping on our living room couch. And I love it. It's so awesome. My parents think it's not great, but Sabrina, that's a fun fact.
Sounds like your dog is a couch potato now.
She is. She is now a couch potato. That is so true.
For the show.
Okay, and last but not least, we have to my right.
Hi, my name is Fiona. My preferred pronouns are she, her. And fun fact about me would be I was born in the capital of Canada, which is Ottawa, Ontario.
What?
I
didn't know that about you, Fiona.
I didn't know that either.
Cool. Did you ever live there?
From when I was born until I was 2. so I
Okay.
don't remember it.
No, probably not. If you did, I'd be very impressed. That'd be pretty cool.
Crazy. Okay, we want to start today by acknowledging that we are on treaty territory. We also recognize that we might have viewers watching from other treaty territory or unceded territory, but we're coming to you live from Treaty 4, which is the traditional land of the Nehewak, the Nakaway, the Lakota, Dakota, and Nakota peoples, as well as the traditional homeland of the Métis Michif Nation. So we're super grateful and thankful to be here on this shared land today, and thank you for taking a moment to recognize or find out what treaty territory that you are on today. So our episode today, we want to give you a little riddle to kind of get you thinking about what we're going to be talking about today, to see if you can guess what this is. So here's our riddle, and if you were watching us right before the episode, on our lives, you would have a head start at this, but this is the riddle. I'm sometimes found in a pot, but I'm not stew. I can be a bar, but I'm not soap. I've been known to cause a rush, but I'm not a Black Friday sale. I'm a type of metal, but I'm not tin. I can be a metal, but I'm not silver. What am I? So make sure that you text us in or tweet us with the hashtag CouchPotatoLab what you think the answer to this little riddle is.
My answer is going to be stew, but it looks like...
That's not
That's
right
not the
because it
answer.
says I'm not stew.
Okay.
So we're going to jump right in to our activity today. But wait, what is that?
Arr!
Back up!
Arr,
Whoa, 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 whoa.
mateys! Arr! It is I, Captain Spud Rogers here, and I've been watching you. I've been watching the Couch Potato Lab, and I am a big fan.
What?
I've been sailing the Seven Seas and the Saskatchewan River, stealing wheat and barley and all the other grains. But there's something I want more than grains. Do you
What?
know what it is?
Not my lighter.
Not your lighter, but gold. Delicious gold doubloons. And if I do not get my gold doubloons, I will take over the Couch Potato Lab once and for all.
Not our.
Yes.
No.
You
Please.
have been warned.
I love my job.
You have been warned.
Oh,
What was that? Okay, scientist, we got to think fast on our feet here.
Okay, so he says he
What
needs...
did he say?
He needs gold, or else he's going to take over the Couch
Okay,
Potato Lab.
we cannot let that happen.
We need
So
gold.
we need to think. We need to brainstorm.
Gold,
we need
gold,
gold. Okay, my scientist, I'm really relying on you right now. We need ideas. Gold. I mean,
I'm stumped. Fiona, what do you got? What do you got?
Fiona, do you have any ideas about
I
what we could do
think-
here?
I have an idea.
Okay, let's do it.
All right. I'm going to transform normal coins and I'm going to make them into gold coins.
What?
Can we do that?
That doesn't seem possible.
Well, I have a little secret to tell you.
Okay.
And don't tell the pirate.
No, we won't.
They're not really gold.
They're not gold.
I'm
But-
just
okay.
making them look gold.
So we can trick the pirate is what you're saying.
Yeah.
To
We're
save our
making
show.
Yes.
Pseudo gold coins?
Yes.
Okay.
This sounds complex. Okay, what's going on? How do you...
All right. So what I've got going here, I have a nice little mixture of water and some zinc sulfate here that's been boiling. And
Okay.
then in the bottom, you can kind of see that there's some solids in there. And that is called mossy zinc. So as you can see in this nice little jar, it's some big pieces, and that's zinc that's been melted and then poured into water so that it makes different shapes and it increases the surface area. So
That looks so cool. Okay.
yeah,
So you got zinc in a beaker.
Yeah.
What next? How is
So-
that going to make gold? Zinc doesn't even look gold.
that is true. But what we're going to do next is I have a nice little coin here. Just a good old normal copper penny. And I'm going to put that into our solution there. So now there's a copper penny in there, and we want to make sure it's touching the mossy zinc as much as possible,
Okay.
because we want to get as much zinc ions on there as much as we can. And once there's zinc on there, it's going to turn silver.
Oh, wow.
Okay, silver
Okay,
coins
so
are good.
Silver's good, but
Yeah.
we're not quite
Not as
there
good as-
yet.
Yeah, not as good as gold.
Not quite.
Whoa.
So I'm going to rinse it off.
With some H2O.
Yeah, good old water. And then I'm going to dry it off here real quick.
All right, silver coins.
Okay, so
Don't worry, pirate, your gold coins are coming.
So we turned it from copper to silver. And now, with the magic of heat, we're going to put it right on this hot plate. And it's going to turn into gold. Now,
Okay, let's cross our
Cook it
fingers
like a
for this.
pancake. Okay.
now I have a secret because it's not really gold. What we're doing, it's called electroplating.
Electroplating?
That is one big word.
Yeah.
Can you explain that a little bit for us, Fiona?
Yeah, so electroplating means that what we're doing is we're making an alloy out of these two metals.
Alloy?
Yeah, so an alloy is two different metals that are mixed together. In this case, we're using the copper from the pennies and also the zinc from the mossy zinc that we used.
Zinc and copper.
Yeah.
Okay.
So once that is all done, then we end up with a lovely gold coin.
No way.
Yahweh.
It worked. Oh my gosh, you're a
Whoa.
lifesaver.
So,
Okay, now why don't you show the audience the original penny and then compare it to the gold one? That's quite a difference.
yeah, so as you can see, let's see here. I have a
Oh yeah.
yeah.
The pirate's gonna love
Fool's
this.
gold.
You
All
see
right.
that?
That is fool's gold. I've also heard that the combination, the alloy of copper and zinc together makes the alloy, and it's called brass, right? Yellow brass. So if we got any trumpet players, tuba players, trombone players, you're probably part of the brass section in your band. So this is how they make brass, I assume. I'm not an electroplating expert, but we made
Okay.
brass.
That looks great, Fiona. Thank you so much for saving our couch potato lab, but I don't know if one coin is going to be enough. So
No, yeah,
we have
we-
one coin, but Kavina, do you have any other ideas of what we could do to make sure that our show doesn't get stolen?
You don't think one coin's enough?
I don't think so. That pirate seemed pretty angry to me.
He seems very impatient too. I think
Yeah.
we need to come up with some more
Ideas.
some more gold, right?
Yes, I think
okay,
so.
I got a little confession here.
Okay.
This isn't a very popular opinion.
Okay.
I'm a big math fan.
I love math.
I know there's folks at home that like math, and even if you don't like math, I think let's do a math activity
Okay.
because I have this one in mind. It's gonna blow your mind. Okay, so there is a special number, and it's called the golden ratio.
Okay, gold.
So if we can trick the pirate into thinking that there's gold in their body, then maybe he'll leave us alone, right?
For sure.
Okay, so the number on the screen right now is a very specific, very special number. It's called the golden ratio. The number is 1.6180338, and then we don't have all day, so you can read the rest if you want. But that's the number. So we'll just round that to 1.6. That is
Sounds
the
good.
golden ratio number. So here's a little bit of what that number means. A bunch of scientists and mathematicians, they observe lots of different things, and they also do a lot of measuring when they're observing. Okay, so lots of scientists, they're going around nature, they're going to measure maybe the height of a tree, or the width of a seashell, or the height of a human, and then the arm length of a human. And what they're finding is a lot of these measurements, they're somehow all related, and they always equal the golden ratio. So basically, you can take two measurements, and if you find the ratio between those two measurements, oftentimes it equals 1.6. So there's lots of measurements in our human body that we can do, and the ratio is 1.6. So thank you, Sabrina, for the whiteboard. I'm just going to bring this over. Okay, uh-oh.
Did Kavina
There's a
write
wo-
on the whiteboard backwards?
I gotta, oh no, I didn't.
So don't forget to text us your questions, follow along with us, use our hashtag on Twitter, Couch Potato Lab. Hit us up on all of our social media. We have Facebook, Twitter, Instagram, at Eyes Youth all around if you have questions. And to make sure to send in your pictures of what's going on today, what you're doing.
All right, so the golden ratio, if that wordy explanation didn't really make sense to you, I'm sure if you just see it on the whiteboard, it will. So what you can do is take two measurements, and you can find the ratio. If you want to know more about ratios, we did a whole episode on it. It's episode number 9. So go check that out and you can learn a little more about ratios. So basically we're taking the larger measurement, dividing by the smaller number, and hopefully we'll get 1.6. What's fascinating about the golden ratio as well is the second equation here also will give us 1.6. Now not all numbers will do this. Okay, so we can take the large number, add it to the smaller number, and divide by the larger number, and we'll also get 1.6. So we need to find some measurements in our human body that when we divide them together and plop them into this equation, it'll give us 1.6. Okay? Think we can do this?
I think we can convince the pirate that this is more gold.
Yeah.
I really do.
I'm convinced there's golden ratios in our body. So let's do that. Fiona, do you want to start? Do you want to kick one off?
Yeah, for sure. So I'm going to do a pretty fancy golden ratio in my legs. So here I have some lovely tape. First, to find the golden ratio, we're going to measure from your hip. And then that's going to be your big number. And then your little number is going to be at your knee. So I have my handy dandy measuring tape here. All right. So if I look here, I think my hip is about 80 centimeters. All right, so that would be my large number for the golden ratio. And then if I were to look at my knee, I would say it's about 52 centimeters. And that is the small number for the golden ratio. So if we use the formula that Kavina went over before, of the large number divided by the small number, I get 80 divided by 52, which equals...
Let's do the math.
Oh, quick brain math.
Dun, da, da, da.
1.538.
You're right.
That
You're
is
spot on. How do
pretty
you know that?
close.
I'm just really good at math.
Mental math. Did you do a lot of mad minutes when you were young?
Yes.
In elementary school?
Yes,
That would do
a
it.
lot.
Folks at home, if you have to do mad minutes in your class, they will come in handy one day. You can be like Fiona.
Yeah, so 1.58 is pretty close to 1.6, and there could also always be errors in our measurements too.
For sure.
So that might be why it's not exact, but it is pretty close. So I would say that my legs follow the golden ratio.
Wow, okay.
So Fiona, would you say your legs are golden?
Made of gold.
Oh, I
Is that
think
what-
I am made of gold.
I think that is what we're going to go with. So we have our gold penny, our golden leg. Kavina, what else is golden?
What about our height? Do you think our whole body has gold in it?
Let's try.
Okay,
I
let's
mean,
try.
What do we have to
because
lose?
in science, if you have one piece of evidence to support your claim, it's not enough, right? We
No.
need more evidence. So,
Yes.
let's do our height.
Okay.
So I've done this a couple times because I'm a big fan of the golden ratio. So I have already put markers down of where my height is. You can do this at home too. You can just stand against a wall, put a piece of tape where you're standing, then you can back away and measure to the height of the tape. It's a little easier than trying to measure your actual head. So let's measure the height. Oh,
So Kavina, you want to make sure you're measuring tapes on the ground when you're doing this, correct?
yep. Nice
Perfect.
and level on the ground. Go all the way up. We have 167 centimeters.
Ooh, how tall are you, Kavina? What does that convert to in numbers that I understand?
You don't understand centimeters?
I don't understand centimeters.
That's about 5 feet and 6 inches.
Okay,
Yeah.
cool.
Okay, so 167 is our larger measurement. Actually, Sabrina, do you want to write this down?
Sure.
167 is our larger measurement, and our smaller measurement. So my smaller measurement, I'm going to do to the top of my hip. So if you feel your hip bone right there, I'm going to measure to the very top of that, the hard bone. Okay. Done. Survey says 104.
104 centimeters.
Yes. So that's, now these are from last time. You want to put them in there just so the viewers at home can see that. So our large measurement is 167 centimeters. Smaller is 104. Drum roll, please. I'm going to do the math on my calculator. 167 divided by 104. Answer is 1.6.
1.6 exactly?
That is the golden ratio.
Wow.
My body is made with the golden ratio. Now let's do the second measurement here, just to see if
let's
this
check it out.
equation is also correct. Then we know we have a golden ratio.
Okay, so my large number is 167
Yes.
plus my small number divided by my large number.
Yep.
What do we get?
Drum roll, please. 1.6.
Wow.
Woohoo! Okay, so we have more evidence that the golden ratio does exist in nature. We took two measurements in my body, and the ratio is 1.6. Just a reminder. Oh, sorry, I didn't have to move that. Sabrina, I'm going to test you on this, actually.
Okay,
Just a
I'm ready.
reminder. Because we are doing a little bit of math, I think it's a good refresher. What is the top number of a division? What is the top number of the ratio?
Like in mathematical
what
terms?
do you call it?
I think it starts with an N.
Yep.
A numerator.
Numerator. Nice. What about the bottom number?
And then I think it's a denominator.
Yeah.
Okay,
Denominator.
there we go.
A numerator and a denominator. I thought that would just be a good refresher.
Yeah, absolutely.
For sure. Okay. Okay, so we have
There we
two
go.
pieces of evidence that the golden ratio exists. We could do this all day.
We could.
Measure our dog Skylar, who is around here somewhere. We could measure a seashell or a sea star or many other measurements, but I don't think we have time. So
No. So if you're at home and you are interested in what's going on and you want to keep on going, there's 2 more measurements that you can find in our lab manuals, and you can always find those at bit.ly/couchpotatolab. So make sure that you, if you're interested and want to keep going, you can do those measurements. But for now, Fiona, I think that, do you think this is enough? Do you think that we have enough, Kavina?
I think so. I think we need to. Should we? I don't really want to do this, but maybe we should call the pirate back in, or
Should we?
Pirate, are you there?
Arr!
We have your gold.
Arr, mateys.
Yeah, we have your gold. We have your gold.
We have some gold for
Is
you.
she done, this gold?
Yes,
Arr.
the gold has been made.
Is this it?
Yes.
What do you think?
We have a golden coin there for
Yes,
you.
it's a golden coin.
Arr, let me inspect.
It's real. It's real.
It's real. It's
It must be a joke.
It's not a joke.
I didn't spend 6 years as first chair trombone at Pirate College to know that this is brass. You've tried to pull a fast one on ye.
Yeah.
What else do you have? Real
okay,
gold?
well,
Arr.
I'll tell you right now. Your body is made out of gold. I'm serious.
Arr?
Yes. Do you like
Gold.
math too?
Math. I didn't take that in Pirate College.
I'll tell you right now. So take this calculator. You can have it. There's a thing called the golden ratio. You can
Arr.
take 2 measurements in your body,
Arr.
find the ratio of them, and there is a common number, 1.6, that keeps appearing in nature. So
Arr.
that's a golden ratio.
Very
Gold,
interesting. Arr,
Yeah.
very interesting.
You can
but
find it lots of places in
A dolphin
in your
fin.
legs.
The
in
Mona Lisa, the Eiffel
the
Tower.
Eiffel
even.
Tower.
Arr, I'm a pirate, you see. I'm out on the 7 seas. I've got be no time for measuring.
Don't look me in the eyes.
What I
Scares
need is
me.
real gold. I'll give
gold?
you one more chance. I'll be back, Couch Potato Lab. Arr.
Oh
Oh
no.
my gosh. What are we gonna do?
I don't know.
Okay, none of that worked.
Sabrina, have our viewers help? Can we get their help or anything? What do they think? What's their ideas?
Okay, let us know what we should be doing.
Please.
Help us, text us your suggestions to 306-570-1013, and then we can maybe figure this out so we don't lose our show.
Yes, please. I'm
Okay,
begging you.
so while we're thinking up ideas and getting
okay.
all of these ideas, we have one question from the Hayes brothers. The Hayes brothers ask, why is the golden ratio one specific number? So, Kavina, can you answer that?
Why is it one specific number? Like, why is it always the same number? Or, I'm actually not. I wish I knew more about what they were trying to ask.
Okay, so
Like, why it's always 1.6?
so
Yeah, okay.
why is the numerator bigger than the denominator in the golden ratio?
All right,
So I guess when the let's figure out why the numerator can be bigger than the denominator first.
Okay. So the golden ratio was kind of discovered over 200 years ago, a long, long time ago. And the actual mathematics, and you remember when you do math questions, you always have to show your work. Sometimes showing your work takes pages and pages and pages. Well, these mathematicians, if they were to show their work, it would be a whole book of how they discovered these two equations. So we don't really know all of what's going on in these equations. We're not really sure why it's 1.6, but we are just given these to work with. If you'd like to be a mathematician and study why this is the way it is, then yeah, you can go to university and learn that. But so 1.6 here, why is it always 1.6? So, okay, Fiona's measurements. Fiona, what were your measurements?
My measurements were 80 centimeters for the
80.
large
Yeah.
and 52 centimeters for the small.
Don't you find that fascinating that you can have a different numerator and a different denominator? So Fiona had 80, I had 167. Fiona had 52, and I had 104. So these are different numerators and denominators, but the ratio is always 1.6 because the ratio is a proportion. It's how many times the large number can fit into the smaller number. Does that make sense? It's
Right.
a proportion.
So when there's a larger number on top, and you can correct me if I'm wrong, Kavina, it just means that it is a whole number and a fraction. So if we just had a fraction, it would be 1/2, and that's part of a whole. But when we have a bigger numerator on the bottom, or bigger numerator on the top, it just means that there is like whole numbers and fractions.
Yeah, a
if
whole
that
number
makes
and then a
sense.
remainder.
Right. So
A remainder of
I don't
6.
even know. You learn about that farther on in mathematical life.
Yeah, if you go to university, you'll be lucky you get to take more than one, probably 2 or 3 math classes. You get to learn a lot
So
more.
I guess while we're talking about like why this number is 1.6, I want to see if it applies to chemistry because I love chemistry. I want to be a chemistry teacher one day. So I have baking soda and some shaving cream, and if I mix these together I want to try and use the golden ratio to see if this is the perfect reaction combination. And so if you go back to our episode about ratios and reaction-based ratios, again, we were trying to find the perfect combination of baking soda and vinegar to make a baking soda vinegar volcano. And I'm very curious to know if this 1.6 golden ratio would make the perfect baking soda vinegar volcano. But for now, I'm going to use this whole thing of baking soda. Just going to use it all. We're not short on baking soda. So this is my 500 grams of baking soda. So this is going to be my larger number, Kavina, for my
Okay, I'll
math,
put it on the board.
if you want to put it on the board.
For
Here we go. And I don't really have a great container to use this in, so we'll see if this goes well. And then I'm going to use about 300 grams of shaving cream. Is that the perfect ratio? Fiona, do you want to check my math?
Oh, goodness.
Is 500 divided by 300 the perfect golden ratio? Am I supposed to shake this?
The shaving
Directions.
cream?
Yeah. Shake well before
Yeah,
using.
shake it.
Here we go.
How do you know how
Do
much
I know how to use
300
this? Not really.
Never use shaver cream?
There we go.
Ooh, fluffy.
Now I'm going to have to get a little messy, but science is messy, so.
The best science is always messy. Fluffy. It's scary. It looks edible. You just want to take a bite out of it.
Looks like whipped cream, but is not whipped cream. Holy man.
It's a good sound.
This, if I'd known this would
Reminds me
take
of
so long.
Last week's episode.
What was last week's episode?
No, it reminds me of yesterday's episode.
This is
on
getting out of
digestion.
control.
check it out.
And I didn't get a spoon, so here we go.
Ooh.
Would you like some
You got your
tongs?
watch
That
on.
would be fabulous.
There you go.
Thank you, Fiona. Here we go. Okay, let's see if this
So
is
now
going
you're
to make
mixing
some
it.
snow.
Okay, so what are you making again?
It's supposed to be fake snow because I'm really warm right now and I need to cool down.
Huh.
So this is going to help me.
Fake snow. This seems like really fun.
This does seem really fun. I wish I had food coloring. I should have put
Whoever's-
food coloring in here.
If anyone's stuck at home right now, bored, this is a good activity. to
2
just-
ingredients. That's all you need.
Yeah, plop in the bowl.
Okay, it's pretty powdery on the bottom. If I was you, I'd recommend a bowl. This is not great.
Ooh. All right, what does it feel like?
Oh, it's getting so fluffy.
Well, and you know, Sabrina, I did do the calculations in my huge and really smart math brain.
And is this going to
And-
work?
It will work. It equals 1.6 exactly.
1.6 exactly.
What?
Ooh.
Yeah.
Okay.
Okay, so do you think it would work with the baking soda volcano then too?
Well, do you think this is the perfect ratio of baking soda and shaving cream?
Honestly, it looks like snow. Does this look like snow to you? It's like not super powdery.
Can I touch it?
If you want.
This is not what snow feels like.
You don't feel like that, Kavina? What should I add more shaving cream? I don't think I use this whole bottle, so that's not the perfect ratio technically.
It's kind of crumbly. Oh, yeah. Smells good. Well, if scientists think, yeah, okay, this looks like snow. You can like sprinkle
Yeah,
it
see?
like
It's
snow.
like not it seems powdery, but it's really like it's not that bad.
I reckon this is a golden ratio.
I agree.
It's snowing.
I don't know if you'd want to make a snowman with this, but
Cool. Oh yeah, it looks like snowflakes. I would say
Okay.
it's a golden ratio.
so the golden ratio not only works in our bodies, but it works when we're doing reactions. So test out some reactions. Maybe you want to go back to an episode where we use some measurements, see if we use the golden ratio or see if the golden ratio works better.
Yeah.
And-
maybe like oil and vinegar. We taught them how to make salad dressing a couple episodes
Yeah,
back.
see what's
Check
going
it
on.
out.
And then make sure you can text us, remember, at our phone number, 1306-570-1013, or all of our social medias. We're on Facebook, Instagram, Twitter, so you can use the hashtag CouchPotatoLab. Even if we're not live, you can definitely do it and let us know what's going on. And don't forget to send us your questions as well. We'll answer them as best as we can. Okay, so Kavina,
Yeah.
Fiona,
Yeah.
Yes.
what is our plan for this golden pirate? For the gold for the pirate? Do we have
Do you think the
another
chemistry
idea?
will impress the pirate?
I think like we can tell him about it, but it seemed pretty obvious that he wants actual gold.
Real gold. Okay. Okay.
Do we have anything else that we can offer him? Like I'm scared we're just going to lose the show.
I know we can't lose the show. Okay, I'm really liking chemistry lately. We're kind of on a chemistry train now. I think I got one thing.
Okay.
I've done this. I've impressed my friends with this chemistry reaction as well. It is called Golden Rain.
Golden rain. Okay.
Golden Rain. How would that not impress a pirate?
I
okay?
think that sounds good.
I need safety glasses.
Especially because they like the water, right? Because they're always on the ocean, so they must like water.
True. Okay. I'm going to put my safety glasses on for this. Now, for this experiment, we are creating something called a precipitate, which is little solid particles in a solution. And the precipitate, we need lead and we need iodide. So we need two different elements. Now, if you've heard of elements before, it's a very common thing that we use in chemistry. And there's this chart that shows all of the elements that have ever been discovered in the world. And it's called the periodic table. So
Ooh.
maybe we'll pop one up on the screen just to show you what that periodic table looks like. Now it has all the elements on it. And today
How
we're
many
choosing-
elements are there, Kavina?
Ooh. To be honest, I'm not too sure. There it is, periodic table of elements. So you can see there's different colors, and they're separated based on the type of element they are. They're also organized by how many protons they have, how much they weigh, and they're all assigned with numbers as well. So we're going to use iodide and lead today. So we're going to choose those two elements to make a precipitate.
A fun fact about lead, you would think that its symbol on the periodic table might be Le, Ld, but what is it actually, Kavina?
It's PB, like peanut butter.
I have a fun
PB.
fact about that, actually.
Okay.
I was in school in French immersion, and the French version of lead, it's called plumb bomb. So
Oh,
it
okay.
actually lines up with the PB on the periodic table.
Whoa.
Very interesting.
Awesome. Okay. Are you ready to see some golden rain?
I'm ready if you're ready.
Cool. We're going to do it in 2 different containers. We're going to start with our graduated cylinder. So in here I have my lead. This is actually called lead nitrate. It's a salt, I believe, lead nitrate. And when you put it in here, you can, the lead particles actually have a charge to them. So they're positively charged, kind of like magnets have a positive and negative charge. So the lead has a positive charge. And then I also have my iodine here. And in here we have negative charged iodide ions. So I'm going to pour my lead in to about here. Okay. And now when I pour these 2 together, the lead and the iodide ions stick together and form a precipitate. Do you guys know what color? Do y'all know what color the precipitate will be?
If I had to
Oh.
guess, I would hope gold.
Hopefully
Purple.
gold. Let's see what happens.
Okay, that's real.
Haha. Golden rain, baby.
Okay,
do you
I
think?
think this is great.
Okay. You want to see it again?
Yes.
I want to
Oh,
see it again.
please.
Okay. We'll keep this nice and nearby so the pirate can see it. Let's do it one more time. Pirate, you watching? Better be.
Arr.
Ah, there he is. Okay. So I got my lead in here. Here we go. Drum roll, please. I say that along this show. It's fun.
Ba-da-da-da-da-da-da-da-da. So, Kavina, you were
Whoa.
talking
Rain.
about these positive and negative charges. So, what's going on with those charges in the
So just like,
reaction?
you know what they say, opposites attract, right?
Okay, yeah.
So just like magnets, a positive and a negative charge are attracted to one another. And then they stick together and form a solid precipitate.
So cool.
Yeah. There we got golden rain. What do you think? Do you think the pirate will be impressed?
I hope so.
Me
I
too.
don't know if we can do much figuring.
Okay, well, what do you think? Should we call the pirate in?
Fiona, should we call the pirate? What do you think?
I think so. I think we should call him in.
Okay.
All right. Pirate, come on out.
Arr, arr, I've returned to the couch potato lab.
Yeah.
Have you produced my gold?
Yes,
Yep.
pirate. Huh? 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 What do you think?
What beckons from yonder?
This is called golden rain.
It is
Be careful.
gold, like doubloons in a treasure chest, but liquid, like the
Yes.
salty brine of the ocean.
Don't drink it.
It is amazing.
Thank you.
I have never seen such
Thank
a
you.
thing. Arr, arr.
Thank you.
This is
So?
fantastic. This will work perfectly. This is the gold I have been looking for, but I require one more thing.
Is this not enough? We tried so hard, Mr. Pirate, sir.
I know.
please.
But
Just take the gold and go.
if you want to keep your precious couch potato lab, arr, then you must produce for me a cannon.
What? A cannon?
Yes. You see, as I sail out on the sea, I see a lot of enemies that I must protect myself from. And in order to protect myself, I need a cannon for my ship. Can
Okay.
you make me a cannon?
You know, I think that I can make you a cannon.
Oh,
I don't know. Let me just see what we got in the basement.
Okay, let's.
Actually, yeah.
Okay.
should I stay around? Should I stick around for this?
It might take us a few minutes, Mr. Pirate.
I'll be back.
We'll call you back.
Arr.
Okay. I hope this is it.
I hope so too.
Hey, I think I found something.
Okay.
Oh,
Okay, I found this tube
Okay.
and I found a ball.
How are we going to make this?
Huh?
How are we going to make this a cannon?
Okay, I think I got an idea.
Okay.
Does anyone have something really flammable? Sounds scary, but anything flammable around here?
I think I keep something called ethanol around.
Ethanol?
You keep
yeah?
that around? Do you have some?
Yeah, I think I just kind of just hang out with it down here. I got a little something here.
Yeah, that's ethanol. Pass it
Oh,
over.
okay.
Let's maintain our social distancing. Yeah, pass it on. Oh. Just
There, now
Okay.
you grab it.
thank you. Ooh, okay. All right, this is kind of empty. I'm gonna go down to the basement, fill
Okay.
it back up. Is that all right?
Okay, yeah.
See you in a few.
We definitely don't want to upset our pirate anymore because then we might really lose the show. In the meantime, Fiona, we have a question for you.
Ooh.
Why did you leave Ottawa?
Okay, well, I did leave Ottawa when I was just 2 years old, so it wasn't really my choice. But the reason why we left is because my dad got a new job here in Regina. So my whole family moved here.
That's
Yeah.
great. Very
Okay.
cool.
We got ethanol, we got
I
the
can
tube,
smell it.
and we got the cannonball.
Okay.
We need a target. Do you have
Oh.
a target?
Well, good thing I keep a target just, on my bedside table beside me. Target, and it's perfect for the pirate, X marks the spot.
Okay.
Oh, yeah. Okay.
Okay.
So,
Here.
I've put the ethanol in, and what I'm doing now is whoa. I did drop it. I think
Is our
it's all right.
cannon okay?
I think so. I don't know.
I just
We'll
don't want
find
to
out.
ruin our chances.
So I put ethanol in here, and I'm shaking it. And I'm shaking it to create ethanol vapors. And so when ethanol is in a gas form, it's actually a lot more flammable. And when we light it on fire, those vapors will want to expand. And when they expand, they'll shoot the ball out the other side. Okay, we gotta shake it real well.
Okay.
Hold on a second. I gotta pour it in this hole. This is where we will ignite the cannon from. So I'm gonna add some ethanol
Make
in
sure
there.
this cannon isn't just going to go off.
It will go off.
Well, make sure that it's just not going to go off right now.
Oh, no, Sabrina.
Is it safe right now to be shaking it all over the place?
No. Yes, it is.
Oh my goodness.
We have to add a flame to ignite it.
I'm a little nervous with this thing being.
Oh, I'm glad I'm over here hiding.
Okay, I think.
Are we
I think It's
ready?
all shaken up here. Are we ready?
I'm ready.
Pirate, come over and watch this.
Arr, is my cannon
Whoa, whoa, whoa.
ready?
Stay away. We need to maintain social distancing.
Arr, of
Right?
course.
So I'll give it a light. You watch and learn, all right?
Arr. Okay. Arr, I'm going to stand back here.
All right. Give me a countdown.
3, 2, 1.
Oh!
Arr. Wow.
Is that impressive, Mr. Pirate?
That is, there she blows, I would say.
It's good. We got a little fire on the ground.
That is the most mighty fine cannon I've ever seen. Couch
Okay.
Potato Lab,
Are we good here then, Mr. Pirate,
you
sir?
have done more than enough to appease old Captain Spud Rogers. I will take your cannon,
Please.
and I will go and set sail on the seven seas. Thank you for all of your help.
Yeah.
The Couch Potato Lab is safe for now.
Make sure you take the gold.
Yes. Thank you, Couch Potato Lab, for using science to solve all of my pirate problems.
You're welcome.
Hope to
Never come back.
see you again.
Bye. We did it. We did it.
That was stressful.
I'm sweating.
Okay. Well, we did
job.
it, scientists. We did it. It took some time, but we did it using the wonderful golden ratio, which we have a question about. The question is the golden ratio an improper fraction? So who knows the most about fractions in my scientists here? Who can answer this question for our viewer?
Sabrina, Fiona.
I
wanna-
do
There it
believe
is. 1 point.
that, yes, it is an improper fraction.
Okay.
Yeah, that's what I was thinking too.
I thought so too.
And correct me if I'm wrong, but that is because it does not equal a nice round number like 1, 2, or 3. It makes a number like 1.6 or 1.2. So it has a decimal place. I'm correct, right?
It has a decimal place because there's a remainder, and that's because the numerator, the top number, is larger than the denominator, the bottom number. So we have a remainder.
Awesome.
Well, not always. I mean, you could have 6 divided by 3, and you get
Which-
an answer of 2, and there's no remainder, but that's still an improper fraction because the numerator is larger than the denominator.
Cool.
Yeah.
Learn something new every day. So we have one last pirate joke for you today, and I'm going to ask my scientists to see if they know the answer to this. So what is a pirate's favorite element on the periodic table? And don't think that it's just the first answer that you think of.
Is it lead?
No, it's not lead. I thought it was gold, but it's not gold. So what, Fiona, do you maybe know what?
I think I have the answer.
Potassium.
Is
'cause
it-
They can get.
Is it
No.
argon?
Okay, that's funny.
That's right.
That's good.
You're right. That is the answer. It's argon because pirates, well, you know. Okay. So before we go, we want to make sure that you are texting us your questions. Text us how your measurements turned out today, and make sure that you are checking out all of our social media. We go live about half an hour and an hour before every episode today, so you can tune into those at Eyes Youth on Facebook, Instagram, and Twitter. And always use the hashtag CouchPotatoLab. We love to hear from you. Okay, so the final part of our show, we have Ask Our Scientist.
Oh, yeah. Put
Da-da-da.
us on the hot seat.
The best part. Okay, so we want to ask us your questions about today, about a different episode, anything that you want, and we will try our best to answer them. Our lovely scientists will try our best. And we will have a guest scientist come in. Maybe when should we invite our guest scientist in here?
Let's bring them in.
Right now?
Yeah, right now.
We want to
Let's
see
do
our
it.
guest scientist?
Yeah.
Okay.
Drum roll, please. I love saying that. Guest scientist, come on out. Who are you?
Where are ya?
Hello!
It's
Hello!
hi!
Hey!
Oh,
I-
hi.
You're not going to believe this, by the way. I
What?
saw the craziest thing. You know, I always kayak to work to the
Yeah.
Couch Potato Lab, and there was, going the opposite way, leaving this building, a pirate ship.
No,
Yeah,
no.
a pirate
no
ship. Have you
pirates.
seen a pirate around? He gave me these little booties. He threw them off the,
Hey,
the
they look
ground, and I'm
good.
wearing them now. They look pretty good. But what's that all about?
You won't even believe the day that we've had.
Oh.
No one's gonna believe us.
I can imagine.
Well, long story short, a pirate needed gold. We made gold. We made gold coins. We made
For a
gold ring.
pirate?
For a pirate.
It's amazing.
Yeah, we got some extra gold kicking around if you'd like to have a piece.
Sure. I mean, of course.
Cool.
Of course.
Well, while you're here,
Yeah.
we're gonna give you some gold, but you can't just get the gold for free.
Oh.
We're gonna put you on the hot seat here
Okay.
with an Ask the Scientist question.
Sure. Yeah, yeah, yeah.
Okay, here we go.
Yes,
Are
I'm
you ready?
I'm
Okay.
ready.
Our first question is from the Hayes brothers. Thank you for always tuning in, Hayes brothers. Is everything equal to the golden ratio?
Is everything equal to the golden ratio? That's a really, really good question.
That is a good question.
Now, we've learned, because, while I'm kayaking here, I've always got the Couch Potato Lab set up on my iPad in the back of my kayak while I'm on my way over. And we've learned that there's a lot of things that are equal to the golden ratio. I saw that, like, Kavina and Fiona, you guys are both equal to the golden ratio, which
We
is
got
pretty
gold.
crazy.
Yep.
And there's lots of examples of architecture and other things in nature that we can find that are equal to the golden ratio, but not every single thing is equal to the golden ratio. There's certain things that are equal to other ratios, but not everything in the world is equal to the golden ratio. But there's a surprisingly large amount of things that are.
Yeah.
Yeah.
Good answer.
Cool.
And Cole, did you know this? That some people actually think the golden ratio is a myth. It's a complete myth. People think that we're just measuring too many things to try to find evidence to support what we claim. We call that a confirmation bias.
Oh.
You don't have to worry too much about that word, but some people think it's a myth.
Interesting.
Yeah.
Well, I mean, I don't think it's a myth because you folks proved it to me. I was watching in my kayak and I saw the golden ratio all over the place. That was amazing.
Yeah, we have evidence. Maybe our viewers will message us at home, and maybe they'll have evidence of the golden ratio as well. Yeah.
Wow. Fantastic.
Okay, cool. We have one more question for you before you are just
I thought I
free
was
to
going to
go
get my
here.
gold. Okay.
One more
Not
question.
quite yet. Okay. What body of water did you travel to get here today?
Well, it's a long story. Everything starts for me in the Pacific Ocean. I come from the west, and then I enter in through the San Francisco Bay, and I travel up through the bay into the Mississippi, through the delta there, and all the way up through the Rocky Mountains, And I make my way into the prairies where we call home to the Couch Potato Lab. Eventually, I end up in Wascana Creek and then Wascana Lake. And then it's basically just a hop, skip, and a jump to the Couch Potato Lab. So there it is.
I love that. You
I like
really
it.
know your geography there.
I really do.
You study that. I see that.
Cool. You seem very fascinating.
Well, thank you.
You got a lot of stories that, to be honest, I don't even know if they're true. But I think they're entertaining, and we need to know a little more about you.
Sure.
So what do you say you bring yourself and all your wacky stories, and you come and do a Couch Potato Lab for the next episode?
Do you really mean it?
I
could.
really
mean
mean
it.
it. I
wanna
need
come back?
I need a break
Well,
after today.
I'm normally not allowed, but if you give me permission, then yes, that would be awesome. I would love
Yep.
to.
yeah.
And I'll tell you what. If you do the Couch Potato Lab, I will install a motor on your kayak. You
Really?
can sit back, and it'll take you all the way to the Couch Potato Lab.
That's amazing, Kaveen. I would love
Yeah?
to. I'll do the lab tomorrow.
Yes, do it. Yeah, we need you. It's all
Great.
about muscles. I know you got big guns on you.
Yeah.
So after all that kayaking,
That's right.
you'll know it all.
That's right.
Okay, so thank you so much for coming.
Well,
We're
thanks
going
for
to
having
reward you with some gold coins.
Oh.
Or should I say brass coins? But
Amazing.
he doesn't have to know that.
What? Oh, I
we
thought
have
you
some
said something.
gold
Oh.
coins for
Oh,
you today.
wow. And silver as well.
Yes.
Can I take all of them?
Take them all.
It's amazing.
Please come back tomorrow.
Well, thanks so much, everybody. It was nice visiting. And tomorrow, I'll be on the Couch Potato Lab, and I'll do you all proud.
Yes,
We would
for
love
sure.
that.
Thank you.
Thanks
See
for
you
coming,
later.
Cole.
Bye, Cole.
Bye. Oh, no. Where do I? Hey. Oh, I'm caught. My pirate booties.
Fire. Get out of here.
Okay, a few more
What a good
questions
guy.
we have time for today. Another question we have is, would more ethanol make the cannon fire farther? So if we put more ethanol in our cannon, would that make the football go farther?
Ooh.
Who can
More
answer
ethanol
this?
might mean more fumes, more
Okay.
vapors, more gas being lit, more propulsion. I think that seems
Yeah.
reasonable. If you noticed, when we lit our cannon on fire, there's actually lots of flames inside. We did get a little flame on the ground as well. Hope it's all right. And that's because lots of those vapors, lots of the ethanol didn't get transformed into a vapor. It stayed as a liquid, and then it catches fire. So I think we could have just shaken that cannon a little more, and we could have had a much stronger cannon.
So what you're saying is you just want more fumes. So
More
even if
yeah,
even
yeah.
if we didn't put more ethanol in and we just shook it more, it would go farther too?
I'd say so.
You'd think that?
Yeah.
Very
I think
cool.
we'll try it out again.
Yeah, definitely. We
Sure.
can test our hypotheses on another episode, right?
Mm-hmm.
Okay, so before we go today, we want to do a little giveaway or remind you of our giveaway. We have this awesome little potato clock to give away and a Nice Eyes swag bag. So all you have to do is go back to episode number 5 where I made a little mistake making lemonade. We were making lemonade and putting in lemon juice, water, and sugar, and I accidentally changed one of the ingredients. So you need to go back and tell us what ingredient I accidentally added to my lemonade that made it almost not drinkable. So text us or tweet us with the hashtag CouchPotatoLab. Find us on Facebook, Instagram, Twitter, and more recently on TikTok. We're going to be coming to you soon with some fun TikToks. And then we will announce, you have until Friday. You have until Thursday at 5 p.m. to send us in your answer to get entered to win this lovely clock and an eye swag bag. Sounds pretty cool.
Are eyes scientists allowed to enter? Can I enter, please?
I don't think our eyes scientists are allowed to enter, but you can always go back and watch the episode anyway and have a good laugh.
Oh yeah. Okay.
That would be
Maybe
fun.
have like an eyes-a-thon.
Yeah.
Like an eyes Couch Potato Lab marathon. You can
'Cause
just watch all the episodes.
This is episode 15 already. I can't believe that we're already at episode 15. It's been crazy.
It's been a good ride.
It has
It's doing really good. Thank you for all your support, everyone.
Yeah, so we want to say thank you to all of our awesome supporters like Actua, the University of Regina, Graffiti TV, who we would not be coming to you live without, and all of you for watching, for tuning in, for asking us questions, and all of that. We really appreciate it, and we love the Couch Potato Lab.
Yeah.
Okay, that's it for today.
It's a good way to wrap up.
Yeah.
All right.
Okay.
Bye, everyone.
Bye.
Bye.